And attention is all you need. A groundbreaking paper which gave birth to a whole generation of AI models like ChatGPT. And these models are powered by this magical concept called attention. Attention simply helps the model focus on specific parts in a sequence. So let's say I have a sentence. The lion chased and ate the quick brown. To predict the next word, I will have to pay attention to the words lion, quick, and brown. To the double-balloed, as I said, which should lead me to the conclusion that it is some speedy brown animal which is preyed on by. This should make me predict something like a deer. As you can see, in relation to the next word, the attention on the words such as lion, preyed, and brown were paramount for me to predict the next word. This right here is what attention aims to do. Whether attention is used for emphasizing relationships between words, but its working is similar to a dictionary, but not any dictionary, a fuzzy dictionary. Let me explain. And let's say I have a regular a Python dictionary with entries, name, terminator, and let's have the weight 1000 and the model as T800. Now, say I want to index the query species. This would not yield anything but an exception. But if I somehow index it through an attention layer, voila, it would go, aha, model and species are quite similar. So the user must be querying the model. But theory will only get you so far. So let's take this concept into practice. Let's take some cars, to be precise. Let's take a Ferrari, Lamborghini, Cooper, and a Honda. Now we will represent these cars as vectors, and these vectors will contain values of different features. The features we will take are fuel tank capacity, rating, and max torque RPM. That now, as a Ferrari has a highest RPM here, it has 1.0 as its third value, as you can see, and all the other RPMs are relative to it. As for the fuel capacity, I just divided the actual capacity by 100, and the rating was out of 10. Well, I guess now I want to pair these cars to form a sequence. So let's take one fast and one slow car and pair them up to form a sequence. So let's first pair a Ferrari and a Cooper, and then the Lamborghini with the Honda. Now let's take the Ferrari and Cooper pair as the keys to my fuzzy dictionary, denoted by the matrix K. And for the queries, let's take the Lamborghini and Honda pair, denoting it by the matrix Q. So the first step in accessing this fuzzy dictionary is finding the attention scores. This is done by dotting each query with each key, and can be easily presented with the formula Q multiplied by K transpose You can see that the Lamborghini and Ferrari having similar high values, thus creating a high dot product. Similar to this, well, the Lamborghini and Cooper have a lower dot product because of the low values of the Cooper. These dot products are what we call the attention scores. Really, to make things even more interesting, we'll normalize these scores using a function called softmax, which is sadly not a toilet paper company. This magical function converts a sequence of real numbers into a probability distribution. So we can use this function on the attention scores to convert it to a probability distribution. Now, as all probability adds to 1, we can say that the attention scores are normalized. And these normalized attention scores are what we call attention weights. Now, attention weights are remarkable because they tell us how much attention we should pay to each value. This is based on the similarity of the query with regards to the key. For instance, the Lamborghini query has a weight of 0.7728 for the value corresponding to the key Ferrari, but a mere 0.2272 for the value corresponding to the key Cooper. Well, this is because, as we all know, Lamborghini is much more similar to a Ferrari than a Cooper can ever dream to be. That we want to get our final fuzzy lookup values. To obtain the values, we multiply the attention weights with our values. This gives us the values of the dictionary, but in weighted fashion. Now, as a Ferrari and a Lamborghini are very similar, we will get more of the value corresponding to the key Ferrari. But we never discussed what the values corresponding to these keys will be. Well, it is the key itself. See that one coming, did you? Now, eventually we've been talking about fuzzy dictionaries. Attention solely exists to emphasize relationship between events in a sequence. So keeping the value as the key allows us to tell the model that the query is related to the following words in the key. Let's take language translation as an example. Let's say I have something in English such as gods of death like apples. That way, the Japanese translation being Rindo no Yona Shinigami. On calculating the attention weights, I will get something similar to this. This ties in with our previous claim about attention. And as you can see in the attention weights, attention is helping the model attend to specific words during translating a word. It helps it form relations and attend to those relationships, thus making it a strong tool. It tells us which parts of the Japanese sentence should be attended with which parts of the English sentence. So, as you can see, attention is a mechanism which works like a fuzzy dictionary that helps us attend to specific relations between the words of the query in relation to words in the key. And this ability to focus on specific relations and attending to them makes attention really powerful. So powerful, in fact, that it is placing our jobs in danger. Not me, though. I am just an AI model which runs on attention too. In fact, the very voice you have been listening to runs on attention. well, that's all for today. Uh,